So I got through that one. Now let's do some computer vision. That was, of course, just fitting a simple line, simple graph. But vision is more interesting. So here's a famous one, the Fashion MNIST database, whole bunch of pictures of clothing, and these fit into categories like t-shirt, pullover, dress, coat, sandal, and so on. And so you want to train your machine learning model to recognize the clothing from those images, which are 28 by 28 pixel grayscale images. So we're going to feed in, I think I got a better, here's the input image. It's 28 by 28 grayscale, so those are numbers that go from 0 to 255. We're going to load that up as a bunch of pixels, 784 pixels, and then feed them into a layer of hidden neurons, and then feed them into 10 outputs, which will be the probability that's in each of those 10 categories. Now notice right away one really fundamental problem here. I took the pixels. Now humans will look at this and they will say, well, the edges are black and they don't matter. This is a shape of a coat. Then there's these stripes. So this stripe is like one object and this stripe is one object. Humans pre-process images into meaningful chunks. The machine learning model does not, certainly not a single layer one like this. It takes all the pixels and treats them as independent data. It doesn't even record whether they're next to each other or not. So where I see a region of black, it's just going to see 5 to 150 disconnected pixels. So right away you can see it's going to do something weird, strange, and arguably very inefficient because it's not doing what a human would do to recognize that image at all. And that will turn out to be a big problem as you go ahead. But anyway, that's how it works. So let's see if this one's going to work. I think I'm going to make a new one so I have a new version of TensorFlow because I want to make sure I have whatever problems you people have. So let's make a new one. It's going to make me sign in again because Google likes to be irritating.
No, I wouldn't even give me a problem.
Not as irritating as Microsoft. This one did not give you a problem?
No.
Good, glad to hear it. All right. I taught this class literally like 2 weeks ago and everything was fine, but such is life. That's the problem with Python. The community just ruthlessly upgrades things and has no mercy. Anyway, and they change things. Anyway. However, this Colab environment greatly improved my classes. My students can have a netbook or something and local installs are even more varied and unreliable and give trouble. Okay, here it goes. Notice it's taking a long time to do each step here because it's having to train on a whole set of those images. I think it's, by the way, I should explain this. Here's the training images. First you normalize them. You don't want to let things go from 0 to 255. You pretty much want to restrict all your data to go from like 0 to 1. That's going to come up in later ones, we'll see. The scale of your input data really matters. So you scale it down to where everything goes from 0 to 1, and then you split it into training and test data. And so I think it's going to automatically choose 80% of the data to be training and the other 20% to be test. Because if you train it on some images, it might learn the trend, which is the real underlying population, but it might also fit the specific idiosyncrasies of the training data, which is fitting the noise. So to prevent that, you train it to have a lower error on the training data, and then you test it with images it has never seen before to see if it's accurate on them. That's really important. And so here we go, taking some steps of gradient descent, and here we are at the end. So the accuracy is 80, the accuracy on the training data is 89%, and the accuracy on the test set is 87.7%. So this is what you'd expect. This is called overfitting. If it's more accurate on the training data than on the test data, then it fit not only the trend, but also the noise. And by the way, this is what happened to the large language models like ChatGPT. ChatGPT was trained on basically all the data they could find on the internet, the heap, which is just tons and tons of language. And then the question is, what did it learn? Now, if it really just learned the trend, then it really just learned a grammar book about English and other languages, so it knows how to correctly format sentences. But if it was overtrained, it just memorized the data on the internet and repeats it back to you like Google. And authors wondered, did they train on my book, my science fiction book or something? So they would put in like a page of their book, and it will reply with like the next 10 pages of your book, which shows that it did get overtrained and did just memorize the data. And this means not only is it a technical failure, it's also a legal failure. New York Times is suing OpenAI over this, and they're claiming what you did violates our copyright. And they said, no, what we did was just, you made the stuff available for humans to read. Now a human would read your article and learn from it. they don't just memorize your article and then sell it. So all we did was learn from it. And if they didn't overfit, that would be true. If they did overfit, then they just memorized it and handed it back out to people, and that would be a violation of copyright. So, of course, I'm not a lawyer. I'm sure it's more complicated than that. But anyway, it matters. So now we're down to overfitting just a little bit. So it got up to 89% accuracy at sorting those images, which is pretty cool. So now it would be nice to see how good they are. So let's go here and take a look at a few images. Okay, this is a chart, and what it's showing me is the first number is the correct category, and the columns are the categories from 0 through 9. So this one is really a 9, and it decided it had a 92% chance of being 9, so that's a good match. This is a good match. A lot of them are good. This one here is 6. Okay, you can find the errors by looking for numbers that are below 90 here. Like here's 32 and 58. This is really 7. It got it right. 87 and 2, 99. Here's 12 and 87. I'm not finding one it got wrong this time. Usually it gets like the 11th one wrong. 4, 5, 6, 7, 8, 9, 10, 11. This time it got it right. 5, 7, it was pretty confused about. All right, I'm going to take the 13th one as an example that it was getting confused about. 58%, 32%. That's the 13th one. All right, so we're going to just look at a few of these. And so here it would show me the first one and the 11th one. I'm going to look at the first one and the 13th one this time, although it doesn't really matter. All right. So when I go, here we are. All right. Now we're going to look at the images specifically. So here's the first one, which it got right. And here's the next one, which it got wrong. And it couldn't decide if that was like a sandal or a sneaker, I think, which of course I'd have trouble deciding too. So that's pretty understandable. When it gets confused, it's doing something that more or less like what a human would do in that regard. Now you can train it for more epochs, which will take more time, and if you do, it will do more overfitting. Now it'll get to 94% on the test training data, but only 88% on the test data. So what you're doing, you're not accomplishing anything, you're wasting your time, you're learning bad habits, you're learning to follow the noise, you're not getting closer to the underlying trend, which is a problem with overfitting. All right, and there's a flag defined there. So that's the first machine learning one. And let's take a look at the others. There's a series of machine learning ones here. Breaking a CAPTCHA, for example. Now here's a really lame CAPTCHA where you just take images and you put them in different fonts and tilt them over sideways. So it's not a very strong CAPTCHA, but we're going to practice breaking it. So I'm going to make a new notebook. I'm going to throw this one in the trash. Oh, it's going to make me sign in every time. That's irritating. I might quit making a new notebook if they keep being like this. All right. I don't really need to make a new notebook each time. All right, so this one here, it's going to just download some content from my website, which I got from some open repository, and I just removed a bunch of them to make it simpler. And so it's going to extract these things into images and then plot out some of them so we can see what we got here. And what we got here, let me go to my instructions. Okay, so you see letters like this. The letters are sort of bent over and in different fonts. So we're going to prepare the images for machine learning here. Whoa. See if I can get this correctly grabbed. Okay. All right, there they are. It did that. Let me see what the images look like. This is just going to format them and make a training and test set again so we can try to fit it. And again, normalize them so they go from 0 to 1 instead of 0 to 255 and so on. Get them ready to use. All right, and now we can create a model and train it. And we're using, of course, in these projects, the simplest model, Keras, which is like a high-level machine learning library that makes it very easy to make the standard models. You can't do complicated new stuff, but you can do the standard models quite easily here. So we're going to have an input layer, another input layer that has to do with reshaping the images, then a hidden layer with 500 nodes, then an output layer with 32 nodes because there's 32 possible characters in this data set, letters and numbers, and some of them I think are removed, like an O and a capital 0 that would be confusing. So it's just going to use a standard model and try to categorize this stuff. and the end result is we get up to like 86% accuracy. 92% on the test data and 86%, or 92% on the training data and 86% on the test data. So you can do it, and there's a flag defined there. So that's a simple machine learning project. And let me just do them all in a row here. The last one is one that amazed me. I would not have believed you could do this so easily with free environments like Google Colab, but you can. I think I'll just talk about this one because the punchline is going to take forever. So this one here, you download this data, you get a bunch of blurry images. Now this was put up by camera enthusiasts. Somebody went and took a bunch of pictures of scenes with and without blur by defocusing different cameras. So that's pretty handy. And you can see examples like this. You got a ceiling chandelier sort of thing, and then he's got a blur one. And so I just took a bunch of these and you put it in a training and test sets, and then you can prepare an encoder. This is full color images, 3 colors, and I think it's 256 by 256 pixels. And then you make a decoder, and now you can train the model to turn the blurry image into the sharp image. And this is what I see on TV all the time. They have a surveillance camera, they can't read the license plate, they say sharpen that up, and the AI sharpens it up. It can do it, but you got to understand it's guessing and lying. It will tell you something where you could give a clear answer with a complete disregard for whether it's wrong. But anyway, it turns out you can train this thing, and the original one, when I did it, it took 5 minutes to go through training, and then the results are horrible. It's supposed to turn this blurry thing into that sharp thing, and this is what it produces. 5 epochs of training are not enough to get any good at this job at all. What you have to give it is more epochs of training, and I just gave it like 70 minutes to train, and then a student pointed out to me what I didn't know. Google will not only give you a CPU for free, they will give you GPUs for free to some extent. So you can turn on the GPU in your model, and then you can train it in just a few minutes for 100 epochs, and then it actually gets pretty good. These are images it has never seen before. It can take this blurry image, this is the right answer, the sharp image, and here's the deblurred image, and you can see it's made some progress at deblurring it. So this is pretty amazing, and this is, by the way, how Stable Diffusion works. You go into Stable Diffusion, you say, I want a picture of a dog riding a bicycle in the style of Picasso. What it does, it takes a bunch of Picassos from the web, and then it blurs them in 1,000 steps until they're just noise, and then it trains their model to deblur the noise back into a Picasso. And now, then they start with random noise and deblur it and get a Picasso. And so that's the, I wouldn't have believed that was possible or that was affordable, but it's amazingly possible and affordable. You can do some versions of it even here with these free Google Colab machines. So anyway, that's the computer vision part I want to show you. Yeah. Oh, one of these. Can you people hear me, or do I need one of these? I'll try it. All right, fair enough. Let's see if this thing works.
The feedback's really easy, obviously.
Is it any better? Is that better?
No.
I don't hear anything.
We
Got to turn it on. Oh, this is technology. Okay, there we are.
Yeah, okay.
All right. Anyway, that's good. Let's see. All right, we'll see if that's going to make things better. All right, I'm going to stop this.